Hey guys, in this video I'm just going to do a little bit more instruction on how to do the U-substitution for integrals. So this is another just mini lesson to sort of build off of that Edpuzzle that you watched. Oops, I hope if I knew. There, all right. Yeah, it's just going to build off that video and give you some more practice problems. So a U-substitution is what we do when basically you can't integrate something because we don't have like our general like power rules and chain rules, quotient rules. Everything's a bit different when you integrate. It's a little bit harder because you have to think backwards. So a U-substitution allows us to solve a lot of problems that otherwise might seem impossible. So with this, I'm going to go through and just do some random odd numbered questions to give you some more insight. And the first thing on all of them, what you have to do is you have to choose a U. So with these polynomials where you're like multiplying things, generally is always going to be something inside of a power. So like for this one, it's a pretty easy choice there. You can see that's going to be your U. And then you want to think ahead. Think about when I take the derivative of this, is it going to potentially cancel this part? So will it cancel when I differentiate? That's what you want to ask yourself. This, if you're thinking ahead, it will, because when you take the derivative of this, you're going to get 12v. So you're going to see that's going to cancel with that 12v. So that's going to be good. All right, so let's go ahead and do this. Our u, as we said, is going to be the inside there, 7 plus 6v squared. Now, after we've chosen our u, the next thing we do is take the derivative of this. So we write this as du equals, and the 7 goes away, this becomes 12v, and we have to write dv, 12v dv. So you always got to throw that on there. Because then after we do that, well, basically what we're trying to do is replace this dv as well. So we want to solve for dv. So I like to write it this way, dv equals 1 over 12v du. You can certainly combine that into 1 if you want to, but I like to write it this way, and I'll show you why in a sec here. Okay, so now we're going to write our new integral, and we're going to make any replacements that we can. The 12v we can't replace at this point, so we're just going to write 12v. And then we've got 7 plus 6v. Now that actually is going to get replaced. So that 7 plus 6v squared is my u. So I'm just going to write u to the 9th power. Okay. And then with dv, we're replacing that with 1 over 12v du. So that's what it looks like. Now, generally what I like to do is just rearrange this a bit. And I like to take this 1 over 12v and just write it next to the other one, the outset. So I'm just going to write it as 12v and then 1 over 12v. So those are right next to each other, and I can see they're going to cancel. Then I've got u to the 9th du. Now the goal here is to only have u's left in this integral. So what's going to happen is, well, this cancels with this, right? And I'm left with just the integral of u to the 9th du. So that's good news. That's something I can integrate because it's a single variable. So we're just going to add a power and divide. So this becomes the integral of u to the 10th divided by 10, or 1/10 u to the 10th, however you want to write that. And I should have my integral there. And these two things, when you integrate, the integral sign and the du, they just kind of cancel when you integrate. Now the other thing I do need to remember is my plus c. So u to the 10th over 10 plus c. And then the last thing I have to do is replace my u with what u was, which is up here. Right? And I'm just going to write this as 1/10 7 plus 6v squared to the 10th power, and then plus c. And that is my answer. Now, one thing that you can do, you're not going to be able to do this on everyone because it would take you forever. But what you can actually do is just then check this. So how you would check it, sorry about the bell there, is you take the derivative of this and see if you end up with the original problem. So if I were to differentiate this, this would be, well, the 1/10 would hang out there. We keep the original inside, so we'll say this is dv, so the derivative. Got the 1/10 that hangs out there. The 10 comes down in front, so times 10. Keep the inside the same, 7 plus 6v squared to the 9th. And then times the derivative of the inside, so that would be times 12v. If I were to take the derivative, so then this 1/10 and 10 cancel, so I'm just left with 7 plus 6v squared to the 9th times 12v. And let's see if that's what the original problem was. Yeah, it is. I just wrote the 12v in front. So obviously you could arrange that 12v times 7 plus 6v squared to the 9th. So that was the original problem. So you can actually check every single one of these and see if they work. It is a little bit confusing because you're doing integration and you got to think back to differentiation. It is doable, but again, it takes time as well. So, all right, let's go ahead and do another one. Let's look at, let's do we can do number 5. That's going to be a little bit more challenging, I think. All right, so number 5, generally the choice for the u is pretty obvious for most of these. You can see with this, the u is going to be everything inside here because it's all raised to a 6th power, and you can visualize this 7y or y to the 7th is going to become 7y to the 6th, and we need a y to the 6th to cancel. So that's going to be good. So let's go ahead and try to tackle that one. So first thing I'm going to do is write my u, which is going to be y to the 7th plus 14y to the negative 2 minus 7. So the next step is to differentiate this. So then du is 7y to the 6th minus 28y to the negative 3rd dy. And I know this can be a little bit confusing because you actually take the derivative within finding the integral. So it definitely is confusing, so don't get discouraged. I make the mistake all the time too of like mixing up the rules, so don't get discouraged in any way if you are struggling a little bit with this. Okay. So the next thing we need to do is to get that dy by itself because we want to replace this dy up here as well. So I like to just write this as dy equals and just 1 over 7y to the 6th minus 28y to the negative 3rd du. Okay. So now we can do our substitutions. So we're going to have the integral. We're going to keep this, missing a 3 there, sorry. Integral of 3 is y to the 6th minus 4y to the negative 3rd. And then I'm going to go ahead and write this part next because I think it makes sense to write it next to there. So I always just do that. Times 1 over 7y to the 6th minus 28y to the negative 3rd. We then have this thing that we replaced that becomes our u. So then it's u to the 6th power. And then I still got my du to write there. It is important that you're writing that du at the end, or else technically you can't really integrate without that du. But. Okay, so now we got a bunch of y's in here we need to cancel out. Because remember, if we're going to integrate this thing, the only thing that we can have left is u's and du's. Now, the positive thing is this is a y to the 6th and this is a y to the 6th. And that's a y to the negative 3 and that's a y to the negative 3. So there is a way they're going to cancel. We just need to manipulate this a bit. And it should be pretty obvious that we just need to pull out a 7 from there, right? So if I were to rewrite this, 3y to the 6th minus 4y to the negative 3, 1 over, and I just pull out a 7, so y to the 6th minus 4y to the negative 3. Keep everything else u to the 6th du. We then will now see this cancels with this. So what we're left with, integral, we still got that 3, and we still got a 7 here. So that 3 is going to multiply times the 1, so it's just 3 times 1 is 3 over 7. So it's just 3/7 u to the 6th du. And we can actually even pull that 3/7 in front. 3/7 integral of u to the 6 du. And that's an easy integral. We just add 1 and divide. So that becomes 3/7 times u to the 7th divided by 7. And then the du goes away, the integral goes away, so plus c, which we could write this as just really 3/49. And then that u we need to replace with what u equaled. U was this, y to the 7th plus 14. Y to the -3, I believe, right? Oh, sorry, -2 minus 7. And then plus c. And this should be to the 7th power. All right. So that is my answer. Again, we could verify this solution. How we would do that would be to find the derivative. So we take the derivative of this. Oh, that should be a y. U. Take the derivative of that, and we would end up with the other thing over there. So it might not look that obvious how that would be the case, but if you do take the derivative and simplify it, you're going to end up getting the correct answer. So yeah. All right. And again, I don't expect you to check all of them because that would take too long. All right. So let's go ahead and look at another one. Let's look at number 9. So we'll look at a trig function. For this one, you would generally want to take your u to be something inside of a trig function for number 9. So that's going to be this here, the cosine of all that stuff inside is going to be our u part, just the inside there. So this one shouldn't be too bad. My u is going to be v squared minus v to the 4th. And you can see that was, when we take the derivative, is going to give us with a v cubed and a v. That's going to be good. So then du is 2v minus 4v to the 3rd dv. And then I solve for dv. So that is 1 over 2v minus 4v to the 3rd du. Now I can do my substituting. So I've got the integral of v minus 2v to the 3rd. So that's going to stay the same. Next, I'm going to plug in this stuff. 1 over 2v minus 4v to the 3rd. Cosine of u, right, because I'm replacing that. And then du. And again, you can see this isn't an exact cancellation, but it's pretty obvious you're just going to pull out a 2. I'm just going to assume that you guys can do that. Pull out that 2 over the GCF, right? This is 2 times v minus 2v to the 3rd, so that's what cancels. And so it ends up with just integral of 1/2. So we'd have left over. Cosine of u du. The 1/2 obviously pulls in front. We got to integrate cosine. So we think what derivative gives us cosine when we take the derivative, when differentiate gives us cosine. Well, the derivative of sine is cosine. So it's just going to be 1/2 sine of u plus c. And then place the u with what u was. That was v squared minus v to the 4th. So it's 1/2 sine of v to the 2nd minus v to the 4th plus c. And if we were to take the derivative of that, we would end up with the original problem. Okay. Next up, let's go ahead and do an E problem. Probably be the next best option. So in E here, let's do 13. Generally with E problems, whatever the exponent is, that's going to be your u. So with this one, I'm going to let my u equal 6t minus t to the 3rd. So then du is 6 minus 3t squared dt. Solving for dt, I get dt equals 1 over 6 minus 3t squared du. And then I can go ahead and make my substitutions. Integral of 2 minus t squared. And again, I'm going to write this part next. 1 over 6 minus 3t squared. And then it's e to the u du. All right, for this one, again, pull out a GCF. Hopefully you can tell you're going to pull out a 3. So it's going to be 3 times 2 minus t squared, obviously, right? So that cancels with this. And we're left with a 1/3. So 1/3 integral of e to the u du. The integral of e to the u is just simply e to the u. So it's 1/3 e to the u plus c. We then just plug our u back in, which was at 6t minus t to the third. So it's 1/3 e to the 6t minus t to the third plus c. Once you get the hang of this, it isn't really that difficult. I know it seems hard. You're doing a ton of work, but you'll start to see these patterns. You'll start to see just pull out a constant, and the integration part is actually pretty easy. All right, let's go ahead and do maybe one with a fraction here. All right, let's try number 17. That'd be a good one. All right, so for 17, it looks like our u here, probably going to be the bottom. So let's go ahead and choose that to be our u. U is going to be x to the 5th minus x to the 3rd. So then du is going to be 5x to the 4th minus 3x squared dx. And then solving for dx, it's going to be 1 over 5x to the 4th minus 3x squared du. We go ahead and make our substitution then. The integral of, now we got all of this stuff on, let's see here, 6x squared minus 10x to the 4th. And actually, we can kind of ignore this. We're just going to put it over u. And you might want to even write this a little bit differently. I'm going to write this as 6x squared minus 10x to the 4th. And then this u, I'm just going to kind of pull it out and write it as just 1 over u. It's going to look a lot less confusing if we write it that way. All right, and then I've got this other part here that goes in, and that was my 1 over 5x to the 4th minus 3x squared. And then I'm going to write my 1 over u du. And the reason I'm writing it that way is it just looks less confusing because we know we got to cancel out the x part. And also, as we're thinking about 1 over u, your first thought when you see this 1 over u and taking the integral should be natural log of x. Because when you take the derivative of natural log of x, you get 1 over x. So whenever you see just like 1 over u or 1 over x, and you're thinking of, we're going to be integrating this, think natural log x. All right, so then next part, we do need to pull something out to make this work and rearrange this a bit here. Obviously, if we just rewrite this as negative 10x to the 4th plus 6x squared, you can start to see it's going to cancel, right? If we just pull out a GCF, that is going to be pulling out a negative 2 here, right? So if you pull out a negative 2, you're left with 5x to the 4th minus 3x. So that's what we're going to do to get these to cancel. And so we have a negative 2 integral of 1 over u du. And like I said, whenever you see that 1 over x or 1 over u, think natural log. So negative 2 ln of u plus c. We then replace the u with what u was, x to the 5th minus x to the 3rd. So negative 2 natural log of x to the 5th minus x to the 3rd plus c. That'll be our answer. If you were to take the derivative of this, so dx would be negative 2, And then the derivative of natural log is 1 over u times u prime, if you will. So it's 1 over x to the 5th plus x to the 3rd times the derivative of that, so times 5x to the 4th plus 3x squared. And you can see that was, where's our original problem? Up there. When we do this one, you would multiply that -2 through and write it on top, and that's what you would get. All right. That should be a minus, actually. All right. Let's see. Any other ones here we want to do? Maybe like number 19. Oops. Would be a good one to give a shot. Looks a little bit confusing. Let's go ahead and tackle 19. All right. So for that one, our U choice is going to be inside the radical there. Will be a good U choice. So U is going to be v squared plus cosine of 6v. So then du is going to be 2v. Derivative of cosine is minus sine. I'm just going to write a minus there. Minus sine of 6v times the derivative of 6v, which is 6. So it's actually just du is 2v minus 6 sine of 6v. And then I need my dv on there. So then dv is 1 over 2v minus 6 sine of 6v du. Now we can plug it in on the 19. Integral of 6v minus 18 sine of 6v. And then I've got this part I'm substituting, 1 over 2v minus 6 sine of 6v. And then I've got my u, and we'll write that as the 1/5 power. U to the 1/5 because it's the 5th root, du. With this one, looks like we need to pull out a 3 from this, right? So 3 times 2v minus 6 sine of 6v to make that work. And then it will cancel. So we have just 3 integral of u to the 1/5 du. That's an easy integral. We add 1 and divide. So it becomes 3 times u to the, that's going to be 6/5 divided by 6/5 plus c. For that, we multiply, flip it and multiply. So that becomes 15/6. Then we multiply u to the 6/5 plus c. That can be reduced to 5 over 2. 5 over 2. So 5 over 2. And then place our u with what u was. That was v squared plus cosine of 6v to the 6/5 power plus c. So as you can see, once you get the hang of this, it does just take repetition and practice, and you will get the hang of it. I think we'll go ahead and stop there. I guess for like 27, 28, 29, these, do your best on those. These are going to be most likely your inverse trig functions for those ones. So do your best on those. Look those up. Can't remember if I actually assigned those or not. So go ahead, reach out to me if you are struggling with any of these. Do your best. Make sure you're showing your work. All right, see ya.